Problem 25.23 from homework 4 states that a 2.8 centimeter diameter parallel plate capacitor has a 1.5 millimeter spacing. The electric field strength inside the capacitor is 1.0 times 10 to the 5 volts per meter. And for part A, they want us to calculate the potential difference across the capacitor. So I've drawn out our capacitor, our parallel plate capacitor here. We have our diameter at 2.8 centimeters, and then we have our distance between them at 1.5 millimeters, and our electric field strength. And for part A, to calculate the potential difference, otherwise known as the voltage or capacitor voltage, using equation 25.27, we know that the electric field strength is going to be equal to that capacitor voltage divided by the distance between the plates. So we can just swap those around and solve for our capacitor voltage. So plugging in our electric field and our distance between the plates, which we need to remember to convert to meters, we get the potential difference at 150 volts. So that's the answer for part A. And for part B, they want us to calculate how much charge is on each plate. So we know that our charge is going to be equal to the linear density times the area of the plate. And we know the linear density is just equal to the electric field times epsilon naught, because we know the electric field is linear density divided by epsilon naught. So we just switch those around, and then we can substitute that in for the linear density, and we can calculate Q equal to the electric field strength times epsilon naught times the area. And of course we can calculate the area because we know area of a sphere is equal to pi r squared. We know that our r is equal to that diameter halved, which again, remember to convert to meters. And plugging all that in, we get our charge equal to 5.45 times 10 to the negative 10 coulombs. And yeah, this all ties into what we're learning in chapter 25 with parallel plate capacitors and potential difference.